Good morning. So I'll be starting your artificial intelligence course. So let's start with the introduction. So as we know, here intelligence is how we think. So here in intelligence, we have two parts, artificial and intelligence. So in intelligence, we think about how we think, how a mere helpful matter, that is the brain, can perceive or understand or predict or manipulate the world. So intelligence is what we all have. So a world which is far larger and complicated than itself needs something like the brain to make everybody understand the different things. So for this kind of issues, what we do is that we need to take the matter of complicated things and have to simplify that in our brain. So normally whenever I discuss about a system that is called the cocktail party syndrome. Say person 1 is speaking to person 2 in a large gathering. In that large gathering, you have two persons speaking. Rest of the people are treated as noise by these two people. So what we are having here is that we are able to filter out the person whom I want to talk. Say suddenly I stop talking to person 2, now I start talking to person 3. Now the person 2 may be talking with say person 4, but now I'll not take his input as a input but as a noise and reject that. So intelligence in the computational part of the ability to achieve goals in the world. So that intelligence that we are having here can differentiate between this person one's voice or person two's voice and person three's voice and something. So various degrees of intelligence occur in people, whether it is people, animals, or say some machines and so on. Next, we come to the artificial intelligence. Till now we were discussing the intelligence. Now what is artificial intelligence is not just to understand but also to build intelligent entities. So when it is artificial, the word artificial means it is not something that is biological, we are, or say natural, we are creating that. So in the main idea is that we have to have a machine which is intelligent like our human beings or animals, and actually they'll be running on intelligent computer programs. And what they are doing is that for different kind of tasks that computers are doing, we can discuss it like human intelligence, or say it will have an intelligence on its own, but it should not be confined to the things that are biologically observable. There are different types of AI tasks which I'll be discussing in my second lecture. Before that, let's discuss the AI when we take it based on the behavior. The first part is acting humanly, the art of creating machines that perform functions that require intelligence when performed by people. So it is like the AI should act like human being, or like Rich and Knight, which is a popular book of AI, and I have taken this from that only. They write that the study of how to make computers do things at which at the moment people are better is called AI. So AI should act humanly. That is one of the behaviors that we have. So as based on the definitions given by Cruzel and Richard Knight. But again, one more thing is that it has to act rationally also. So for rationally, what we need to do is that the computational intelligence that we have is uh, it has to do in a such a way that computational intelligence is the study of design of intelligent agent. So intelligent agent means it should act rationally, or like Nielsen said in 98, that AI is concerned with intelligent behavior in artifacts. So here we are thinking that it should act rationally. So AI should act humanly is one of the resolutions. The behavior of AI should be rational is the other one. So human and rational. There is another way of how we can do so is that instead of the human performance or right thing, acting rationally, ideal performance and other things, there is another way is thinking wise. So definitions of AI organized based on thought process or reasoning is that it should act just only acting but thinking humanly and thinking rationally. So you are having four parts: acting rationally, acting humanly, thinking rationally, and thinking humanly. So, in terms of thinking humanly, what we have the the exciting new effort to make computers think, machines with minds, in the full and literal sense. That is what Hogland gave in 1985. And the other definition by Bellman in 78 is the automation of activities that we associate with human thinking, activities such as decision making, problem solving, learning, etc. They are called the thinking humanly part of AI. Similarly, we have thinking rationally part of AI, where we have the study of mental faculties through the use of computational models. So, the computational model, which is acting rationally, should also think rationally. So, that is what Charnack and McDermott gave in 85. And similarly, the study of computations that make it possible to perceive, reason, and act by Winston in 92. So, what we are doing is that we are having four types. One is acting and thinking rationally, and acting and thinking humanly. So, we have four types. So, this is the again human person, right think, and ideal performance. So, these are the two parts. So, now coming to acting humanly in details. The Turing test appraised. This is one of the most popular thing. I think you have seen the movie also about Alan Turing. So in 1950, he gave the Turing test. It was to provide a satisfactory operational definition to intelligence. So what he did is that a computer will pass the test if a human interrogator, if a human is speaking to the computer, he doesn't know that it is a say in this room you are sitting and you are speaking to somebody in the other room. You cannot see him. Now the other person may be a person or maybe a computer. Now, based on the your questioning, you should understand whether the person is computer or human. Now, if you perceive that based on your questions that a person, the thing on the other side of the room is like a human, but actually it is a machine, then that program has passed the Turing test. So Turing deserves the credit for designing a test that remains relevant even now, which is say to the not half century, more than half century now. So AI researchers are mainly devoted to the effort of passing the Turing test, and if anything passes the Turing test, means it has artificial intelligence. So we are trying to duplicate human intelligence, or say make a machine which is perceived as human by other human beings if they are not able to see it, but say question it, or the responses that we are getting from that machine. So first is acting humanly. How do you know whether a AI program is acting humanly? If it passes the Turing test approach. So the computer that we need to process the following Turing tests. These are the four of the Turing testings that we do it for natural language processing, knowledge representation, automatic reasoning, machine learning, and other things. So we have to pass the total Turing test. The computer needs for computer vision and robotics we need total Turing test. So these are the six disciplines of AI which are in nine, and you might have heard about this natural language processing or NLP. uh, is there Some of my students are working on natural language processing. Knowledge representation means what we stored and we know based on what it hears and so on. And automated reasoning to use that is based on whatever data you have, you automatically reason them. And secondly is the machine learning part. Then we have computer vision and robotics, where the total Turing test has to pass, otherwise you will not know that this particular thing is a computer or a human being. Now, thinking humanly, we have the cognitive modeling approach, where we must have a way of determining how human thinks to make the program act like human. And it can be through introspection or through psychological experiments and through brain imaging. So brain imaging means we'll observe the brain. Psychological experiment means we'll observe a person in action and the computer will learn from that. Through introspection means we will try to catch our ideas as they are, and we try to implement the computer program to work in that way. So actually how human mind is working, we have to have a cognitive modeling approach. If we are able to do that, then our program is acting humanly. So these are the three: through introspection, through psychological experiments, through uh, brain imaging, and other ways we can do the cognitive modeling approach. The interdisciplinary field of cognitive science brings the computer models of AI and experimental techniques from psychology and other fields, and to form a precise testable theories of the human mind. Next is thinking rationally. So the laws of thought or approach that we are having, this was given by Socrates, that syllogism. So Aristotle was the one who first attempted this right thinking, uh, or right reasoning kind of thing. So he Socrates carried out that later on. So he provided some patterns, argument structures, and created some uh, uh, proper conclusions from that. So if we say like Socrates is a man, all men are mortal, so therefore Socrates is mortal. So this kind of logic that we are putting, so these logic based things. So in one of your units we'll be discussing logic. So this logic or logicist or syllogism is an idea of artificial intelligence which promotes the different ways in which your different programs are handling the intelligent systems. Okay, so next we go to the obstacles to the logistic reasoning of AI for the intelligent systems, the obstacles that we are having. So the obstacles that we are having, that is that we have mainly two main obstacles. First is that it is not easy to take informal knowledge and state it as a in formal terms. Means we are taking informal knowledge, that is the idea or intelligence behind, see why you like a person or why you don't like it. So this is informal knowledge, it may be just some intuition or something, but we have to formally present it for artificial intelligence. For human we have many things, we don't like the way that this person dresses or something. So we have to provide logical notion, particularly when the knowledge is less than 100% certain. And there is a big difference between solving a problem in principle and solving it in practice. So there are a lot of facts that are there, and say somebody is having lot of degrees, but the interview panel doesn't choose him but chooses somebody else. There will be a reasoning behind it, what logic they put, what the HR put, and what they put while selecting person 2, even though he is not as meritorious as person 1. So there are some issues like in army, a very meritorious student may not be selected, whereas a person who is not very meritorious or is good in following orders is selected. So they have different priorities in selection in army, and then in selection as a manager, or selection as a clerk, or selection as an academician, and so on. If somebody is very good in research but not very good academically, so you may choose him for R&D, you may not choose him from academics. Whereas somebody who is very good in academics but doesn't have some great idea, he or she may come with the idea and then apply in that way. So, although both of these obstacles apply to any attempt to build computational reasoning systems, they appeared first in the logicist tradition. So, what do you have here is that there are different ways in which you are handling the system. So, the main idea is that we have to apply some logic for creating intelligent systems or intelligent AI. So in that we have a lot of obstacles. The main two obstacles that we are having is to state the informal knowledge in a formal way, and solving a problem in principle and problem in practice. In theoretical we can solve something, but practically it may be difficult to solve. So we cannot put mathematical formulas directly into any logic, and similarly we cannot put logical formulas directly into any mathematics. So these are the mathematical terms which are not directly happening for replicating the brain. Next is acting rationally. So the rational agent approach that we have, in Latin we say agent is to do. So we need an agent which will act. So have to have a rational or agent with a common sense which will be there. So we consider the computer programs to be the computer agents, and they operate alone and perceive the environment, persist over a prolonged time, and adapt to the rational change for change. Say, for example, you stay at a home where your mother knows what things you like, what things you don't like. Similarly, a rational agent will be a computer program which will know what you like, think, what you like, and so on. Similarly, that is what Google is doing, or Google AI based things are doing. Means what type of items you like in Amazon and other things, they are applying AI and giving the advertisements of those things. Similarly, there is laws of thought. So in approach of AI, the emphasis is was on correct inference, make correct inference in sometimes being rational agent. Because one way to act rationally is to reason logically. Means you have to act rationally, and reason means you have to have a proper reasoning, proper logic behind why you have acted in this way. So you may get angry on somebody, so there should be some logic behind why you got angry on that person. Or you may love somebody, why you love that person, or why do you like that person. That has to be, there should be some logic and some rational thinking behind that. Say somebody is regularly misbehaving with you, but you still like him or her. Why? So the correct inference that you have to do is not all of rationality. In some situations there is no provably correct thing to do, but something must still be done. So there is also ways of acting rationally that cannot be said or involved in inference. Like, he is always bullying you but still you like him, or she is always bullying you but you still like him, her. So these kind of things is acting rationally may be different for different persons. Say person 1 behaves the similar way in person 2 and person 3, but person 2 likes him or her, or person 3 dislikes him or her. So these kind of things means the computer program has to behave like a person based on some logic, some rationality, some way, so that it acts rationally. So all skills that need for the Turing test to allow an agent to act rationally, so that you feel that the person on the other side is not a uh, program but a person. So whatever is responding to you in the from the next room may be a person, may be a computer program, but it has to act in such a way that even if it is a computer program, you feel like that is a person that is acting. There was a one thing like CD, Alexa, what they are employing in Apple or Microsoft is the same kind of things which may not be up to the mark, and you know that they are not persons, but they will make you feel like a person is interacting with you. That is what your reply bots and other things, they're trying to replicate it. As yet it has not been totally replicated, but we are still on the way. So we need learning not only for erudition, but we, because it improves our ability to generate effective behavior. The rational agent approach has two advantages. Number one, it is more general than laws of thought approach, because correct inference is just one of the several possible mechanisms for achieving rationality. Number two, it is more amenable to scientific development than approaches based on human behavior or human thought. So it is more in general, like laws of thought or scientific development. So this rational agent based approach has these two advantages, due to which that is being employed in the AI may not be 100% employed, but we try to employ it as much as possible. So if we are able to employ the laws of thought or the scientific development time to time based on human behavior updating itself and other things, we think that it acts rationally. Though the foundations of AI that we have are: number one, there are different ways in which the um, uh, AI in day to day, there are main foundations. So there are a lot of subjects based on which the foundations have come. I'll be discussing them in more details in the next class. As of now, first is philosophy. Now, how we relate it philosophy, AI is related to philosophy, because if we have these questions like, can formal rules be used to draw valid conclusion? How does the mind arise from physical brain? Where does knowledge come from? How does knowledge lead to action and those things? So these are philosophical questions. So philosophy is one of the way subjects that help in AI. Number two is mathematics. So obviously mathematics is too much into AI. So what are the formal rules to draw valid conclusion? What can be computed? How do we reason with uncertain information? So these are solved by mathematics. So mathematics is a domain of AI. Number three is economics. How should we make decision? Like when we think, should I do this? It may cost more. I don't have that much money or so on things. So how should we make decisions so as to maximize payoff? How should we do this when others may not go along? How should we do this when the payoff may be far from future? See, you want to help somebody, but if you help him or her, he'll go ahead of you or she will go ahead of you. So will you do it? Now if that person is a near and dear one, you may do. If it is a person unknown, you may not do. And if it is, you are very, say, lenient and very happy to help people, then you may help anybody. Number four is neuroscience. How do brains process the information? So that is another aspect of AI, because if we are able to find the solution, then we can get an AI. Number five is the psychology part. How do humans and animals think or react? You throw a stone at a person, he will come and try to beat you, or he may scold you, or he may. This that is a different thing. But if you throw a stone at the animal, either animal will run away or will come to bite you. So this is the psychology. Then obviously computer engineering. So the computer engineering is how can we build an efficient computer that has the artificial intelligence. And last is the control theory and cybernetics. Means you have to control the whole thing. Engineering is looking into the software part, thinking part, where it will employ the psychology, neuroscience, economics, philosophy, and mathematics. But control theory and cybernetics will how these artifacts will operate under its own control, how it will handle, and so on. So these are the foundations of AI, and this is the introduction to AI. I'll be having a discussion later on once you go through the video, and we'll have, this is the first lecture. We'll come with the next lecture later, uh, the next class. So I'll be continuing with the AI and how, what are the AI tasks and other things. So thank you for your patience, and I hope this first lecture on AI has been beneficial. So